What's up, stats? Welcome to a brand new video on the channel. Make sure before you start watching, like, comment, and subscribe because you can also hit that noti bell to get update on the latest videos for math. All right, that's a thumbnail farm. Hopefully it chooses it. Well, anyway, let's get started on today's thing. Today I actually kind of want to go a little bit deeper than what our notes kind of touch on. I want to go straight into the textbook. Now, if you do have your textbooks available, which is going to be awesome, that means that you left it at home. I'm actually on page 130 and chapter 3, more specifically 3.1, and I'm looking at number 37. And it's bolded, it says linear transformation. Now that caught my eye because what a linear transformation actually is goes way beyond the scope of intro stats. If you look it up, you're going to go down this rabbit hole of just crazy vector spaces. Now, I actually kind of listed basically what a linear transformation is. If you kind of know what a vector is, which you've taken trig with me already all the way through, then you for sure know what a vector is. But it's pretty much just a pointed arrow. And you can actually use vector notation. And if you're into coding, you can actually look at row and column vectors, which if you really think about it, data is essentially just a vector, and it behaves just like it too. But in a nutshell, for any vector in a vector space V that's non-zero, of course, which it's pretty much just an ordered pair with infinite kind of series, a linear transformation for any A and B in some sort of field, the vector field itself, that's non-zero, of course, then essentially what it does is you could just distribute. So if you have it being multiplied, a variable A multiplied to the vector, then it goes to every single one of those components. And if you're adding some sort of constant B to any vector, then it gets added to every single one. So in an essence, it's the easiest concept ever. It's pretty much just saying, hey, everything gets added by the same amount and everything gets multiplied by the same amount. But in mathy symbol terms, it's actually very complex and the nuances are you gotta be very careful with it. Well, anyway, it says, if you don't have your textbook with you, I'll just read it out loud real quick. Benjamin owns a small internet business. Besides himself, he employs 9 others, and their salaries are listed here in thousands of dollars. So, and of course, he has the highest one. Determine the mean median mode for the salary. I did that for you. It's 50s all around, which is pretty nice. But the more interesting questions come from part B, C, and D. Business has been good. If he decides to add $2,500 to everybody's salary as a bonus, what ends up happening to the mean, median, and mode? And then part C is just kind of like a touch upon that. He's like, if everybody gets a 5% increase in their bonus, what ends up happening to the mean, median, mode? And then he also lists a third option in part D, which is interesting in itself, but not quite what I'm going for today. So there's going to be 2 questions posted throughout the video, of course, for your AMI assignment. Question 1, which I'll go straight from the get-go, is the stat of the day. If you don't know what a stat of the day is, well, essentially you just kind of look up a statistic, different from your friends, by the way, and find anything interesting. If you find something interesting, like a topic, kind of like what we do at the end of class every day, post it and let me know what you guys find and post the most interesting statistic you find. And it can't be the exact same one as your friends, so don't do that. All right, let's keep going. So question 2 will be a little bit later, and I'm kind of blocking it here, but for variance and standard deviation, it behaves completely differently. Linear transformation does. And I actually had to prove this in my grad school stats class. Because variance and standard deviation actually are defined slightly differently with function notation. And it's algebraic galore here. So if you're ever interested in what actually happens behind the scenes, that's actually the definition of variance. And the standard deviation is defined to be the square root of variance. So it's pretty interesting. But I'm actually going to go down this rabbit hole right here, and start right there. So this is the definition of mean. It's a fancy way of saying add them all up, divide by however many there are. So we're actually going to see what ends up happening if we add a certain constant to everything. Um, so without further ado, I'm going to kind of prove this. And same thing with this one with the 5% increase, which we'll talk about in a second. But first, let's start with part B. So let's say that you have x bar plus some constant. We'll call it k, because c is kind of obnoxious to write with parentheses. So if you wanted to add k to everything, so that means that, by the way, I'm just going to pull out the 1 over n and factor it out because it behaves the same way. So then you have x sub I, where I equals 1 to n, and you want to add it to everything. So, so let's see how that behaves. Well, first, if you added k to everything, that means that you have 1 over n, and then you have each one, so you got x1 plus k, x plus x2 plus k, and then that goes on for every single thing you have, all the way to the end. So for this case, there's 10 of them, so it's going to go all the way to 10, but we're going to be generic and say plus k. Okay, great. So now, if you think about it, addition is commutative, so you can do them in any order. So let's keep going. You got 1 over n. And then, so let's actually group all of the x's together. So you got x1 plus x2 plus dot, 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 all the way to plus x of n, plus, and then you're going to group all the k's together. So you have k plus k plus k. And because you added it to every single component, you have n of those. So therefore, this, as we know, is just the sum of what we started with. So x of I, for I equals 1 to n. So that's this part right there, plus, and then we have n k's, so n times k, or yeah. And then this gets distributed, the 1 over n. So this right here is x of I for n plus, and then n times 1 over n just ends up being k. And then this is just your mean. So you have x bar plus k, and then that just ends up being k. So therefore, adding a k to every single component actually equals to just adding it to the mean. So in other words, considering that this is getting added to 2,500, so you're adding 2,500 to everything, the mean actually increases by 2,500 as well. It's a very powerful statement and actually saves you lots of time. And it's really cool because you could do it yourself, but the new mean would actually end up being 52.5 because it's all measured in thousands. So it's really cool. And you don't have to add 2,500 manually to every single one to recalculate the mean. And the median mode kind of follow the same suit too. So the same thing can actually be done with the 5% increase, where I'm going to erase this, by the way. So then 5% increase. So essentially what you're doing is adding 1.0, multiplying 1.05 to all of those things to get the 5% increase. Does that happen for everything? Actually, this is much more elegant. So let's actually use another variable. Let's call it m. So what happens if you multiply all your components by m, essentially? Will that actually remain in just multiplying by the mean by m? And it's not as, actually, it's a lot more straightforward than you think. So, because if you're good at factoring, then this is a very elegant thing. So times m. So then you just factor out the m. And Uh, it's very easy. Which that all over n is essentially just, yeah. So it's very straightforward with just factoring it out. Now, your second question for the thing for your Google form is actually going to be a more interesting one. Does multiplying any number and adding any number change the standard deviation? I'm going to kind of research that. It's actually very hard to kind of prove and see it, but just give a basic explanation of one or the other. So, um, does it change it or does it not? You can think about it pretty deeply, or you could just think about it from what is an actual standard deviation. So, question one, stat of the day. Question two, does adding and multiplying or applying a linear transformation, how does that affect the standard deviation? Cool. Well, anyway, if you have any questions, let me know. Um, cool. See ya Wednesday.